uh, more than a decade experience, and he's this is exciting talk because he'll be sharing how he uses AI and data analysis for customer analysis. What do you say?
Thank you, Karan. Uh, okay, I'm talking. Let me just the right of the screen. I'm today I'm speaking about analyzing customer churn rates and also reviewing using how we could use logic programming in data analysis. About myself, I'm Siavash Mohammady, 10 years of programming experience. I work in 6 agricultural GIS system, contributed in 6 projects, and contributed in 2 BI solution in the agriculture uh, rural industry, and the other is developing a seniority model of closure developers with a team of 3. My closure journey is I was curious about how could we build a low-code platform, and for that I reviewed several languages. Uh, and at the end I found Clojure and learned Clojure and worked for a Clojure company with name of Lexiana for 5 years. One of my colleague in the Flexiana is presented here, which is Mr. Wood, and one very counterintuitive phrases he said that a senior developer is doing less and is encouraging other people to do less. This is something that at the first glance is meaningless because everyone should try hard, do the lots of things, but doing less sometimes means finding a very creative way to reduce the whole required work. Here in this presentation, at the second section of presentation, I'm showing you how you could do less with using logic programming. Okay. Uh, as I told you before, presentation has 2 sections. The first part is related to conventional data analysis of a Yuga Center customer churn rate. The second section is using AI for data exploration. In the first section, we review what is churn analysis, the problem statement, limitation of our data, some hypothesizes, and the final phase is data exploration. And in the second section, we will see what is conventional approach and their bottlenecks, what is vision of using AI for data mining, limitation of LLMs, what is our design pattern, and I think one example. Okay. Churn analysis. What is churn? In both physical and SaaS services, physical companies and SaaS services, when a customer do not buy from us anymore, it is called churn. It means customer is going away. And it has really big impact on the total revenue of a company. For example, just increasing 5% in churn rate could decrease customers in factor of 3 in this graph you can see. There are other important metrics like cost of acquisition of customer, lifetime value of a customer, and as I said before, churn rate. When lifetime value of customer is higher than cost of customer acquisition. It is a good and successful business model. So why churn rate important? Because it uh, increases the lifetime value of the customers. When our customers have a recurring buy from us, and it takes more time, it takes, for example, 2 years instead of 1 year, or LTV would increase. Okay. The problem of we want to find or we want to solve is what is the churn rate of our yoga center, and what are possible factors that are affecting our churn rate. Limitation of data is there are no data on campaigns and marketings. There are some data on the Google, but not yet integrated to the system. There are no track of people who are leaving in middle of the courses, in middle of the semesters. Single session course are not registered, so there are some courses which are maybe they are private. There are some donative course, and there are some group course which are just a single session, and none of them are registered in our database. So we have no data over it, and it could affect the quality of our suggestions. And we have import some data from our previous site, and that previous site does not hold some data, so we have lack of data for about half of our customers. So this is our database schema. The center point of it, a course calendar register table, which somehow join customers and course calendar. Some hypothesizes which we can think about it. How could they affect in? How could it affect to the churn rate? Is course format? Maybe it is online, maybe it is offline. Could affect the churn rate of the customers. Geographic behavior. Some customer in different part of the country could behavior very differently. Also, course registration pattern could impact how people are joining to the sessions. For example, some people start with asana, some people start with yoga nidra, and so on. Do they have any impact or not? Is teachers impact on the churn rate? And there is also one other hypothesis, device-specific behaviors. For example, if somebody joined classes through the tablet or laptop or mobile, does the device or medium of the class has any effect on the churn rate? Okay. Let's start the data exploration. The first table is author, which is, I mean by author is teacher of the course author. Other table is course. One thing to mention that there are a course has different category. Basic, mid, and advanced are related to the asana and physical exercises. Special courses are those who are which are related to something like breathing, yama and niyama, and so on. Also, we have a city table. Just to mention that some of our customers are from abroad and from outside of the country, and we just add some dummy state for them. And we can see the course calendar. Here we have gender, we have course days, course type, course ID, and we have the course calendar info. We have a course register, which I told you before, it is the central and somehow the most important table. And because we have a separate teacher course teacher data set, We use joining to join those two to the course calendar. Okay, it is course register info. Simple demographic analysis. We can see that this is some deviation in the people who are in different states, and the last one, which is 60, which is related to the customers from abroad. Okay, now we are selecting the how much each customer is stayed at our yoga center, how many months. We see that most of the customers are just revoking their subscription after the first month, and some other about 1,000 revoking their subscription on the second month, and so on. So somehow we have very high churn rate at the first 2 or 3 semesters. And also we have some very loyal customers who are uh, subscribing for 60 semesters, which are somehow outlier in this case. For analyzing the main customers and do not considering the outliers, we just getting the 10 number, and this is the graph by omitting the rest of the app. So we would define the churned customers that are revoking their subscription after a month. Okay. For analyzing, we need to join the databases, customer plus course register. We combined it, then we combined it with a course calendar, and then we combined it with course. And also because dates are include both time and also day of the month. We just interested in the year and the month. We are correcting the format of important dates. And we now can see the churn trends. So by running this query, we can see that join per year and month. The first column, as you can see, the first bar, which is really high, is importing our customer data from the previous site. And if we filter how many of our customers are revoking their subscription after one course, we could see that we have a 500 at the first month, and in the early 2003, and we cannot understand anything from this chart because we do not know how many people are joined and how many of them are churned. So we need to calculate the percent. Here is the percent of churned customers based on the joined user, based on the new users. And as we can see that we have really positive slope, a positive trend toward churn rate. Even if we consider churn for 2 months, we have we will see the same positive trend as well. So by seeing this positive trend, we would conclude that there is a root cause of this churn rate. We develop some hypotheses for this issue, maybe because we change our server from some technology to Big Blue Button. Maybe it is the issue. Maybe new teachers is the issue. Maybe some teachers decreasing their performance. Okay, as we say it is the orange line is time off. We change to the big blue button, so it could be the issue. But what about new teachers? By seeing when teachers join our center, we see that we have hired some teachers at 2025. And if we consider that, it could be the reason as well. Okay, now we want to see the churned students are related to which teacher. So we make teachers and students and teachers churn the student datasets and combine the two datasets and calculate the percent. So we see some negative slope over the experience of the teacher, which is related to the total students that teacher already has, and the churn rate. We can see this negative slope somehow is showing that older teacher has lower churn rate, and the younger teacher, I mean, new teachers have a higher churn rate. The managerial implication is that we need to have some knowledge sharing session between old and new teachers to uh, uh, know how to help the students and how to keep the students. Okay, it is the first part of session. The second part is how we could use AI for data exploration. Data exploration is kind of psychoanalysis. In psychoanalysis, you guess something about your patient. You start questioning her, and by going back and forth, questioning, developing some hypotheses, dig down in your patients, you finally understand that what is her problem. The pseudo procedure for data mining is start understanding the data, guess what is the issue, deep dive to the data, test the guess, and if we do not guess correctly, we can we can create another hypothesis and guess again. As we can see in our tables, this is pretty simple table, so there is nothing uh, hard about it. But what if we have a big data set? If we have big data set, conventional joining data sets and exploring data is not so effective. I have a recent BI project. It is related to agricultural information of village. It has 700 tables. Some tables have huge number of columns, like 50 columns. There were a geospatial relation between tables. Some tables uh, have geolocations. Some tables have GOM field types. So you need geo queries, which is completely different with normal relations. Hard coding was not possible, and I cannot use change from the Postgres to the Neo4j. So for that specific project, even writing simple joins take huge amount of time. So you can see when you have huge number of tables, testing one hypothesizes is take uh, huge crazy amount of time. And also there is not possible you can query things or have a center table, then you can map reduce that specific table and get all information from that. So what was the current alternative? There is one tool in the market. It's called LangChain to SQL. It was not even working for the simplest queries of that data sets. And also its result was not consistent. Means the same question, the same data set, and you would get a different answer, which is not acceptable from reliability point of view. So what is the solution? How could we use a tool like Magnet to find a nail in the haystack? Our vision is user prompt, ask from the artificial intelligence and get the report. Current trend or current tech stack is using tools. So agents are using tools, LangGraph, which is something that could manage complex workflows, and using multi-agents, which could be in different patterns like hierarchical, custom, and so on. The issue is the result, as I told before, is not reliable. You ask question one time and the single question give you different answers. This is not a time efficient if you use multiple agents and each agent uh, takes sometimes for getting response from the LLM, and this is not a very efficient way. And even if you can manage to do things through bunch of agents, uh, it's this is very expensive. It's maybe for even it would be more expensive than using a human for a mouse. And at the end, for some domains, it is not working. LLMs have some features and limitations, and if we want to use the LLMs practically, we should know what are their advantages and disadvantages. One advantages of LLM is solving very general things, solving abstract problems, ideating about things. And their limitation, first, they could misunderstand the user's intention, and they are not very good and very precise in solving a detailed thing. Uh, LLMs are like architects. Architects could build very great models, but architects are not engineers. They cannot calculate our technical requirement. So what is our novel design pattern? Okay, let's consider that we want to build a house, a construction. We need a PR, we need an architect, we need top manager, and we need workers. Or PR is natural language processing, in this case, entity recognition, or architect is LLM, or top manager is technology like LangGraph, and or workers are tools. Okay. Uh, PR gives prompt to the top manager. Top managers give the task to the LLM or architect. Architect give tasks to the engineers, and engineers are dealing with the workers. But who are the engineer here? Okay, engineer here is the rule engine, but we cannot use Prolog. We are using Clara for our rule engine. So our rule engine is a mediator between LLM and tools. Clara features, Clara have some features. It is very fast, it is reliable. You could use tools in the body of the rules, and it can translate abstract output of LLM to the detailed output ready to be used by tools. Design pattern in detail is uh, something that the picture I showed to you. user prompts by entity name recognition. It is then passed to the LLM. LLM generated high-level DSL. The high-level DSL is then passed to the rule engine. The rule engine is generating a low-level DSL, and by using closure postwalk, each part of DSL is parsed by postwalk and different extension, and based on each part, it would use different function, data source, or data processing. What is why we use both LLM and logic programming? We use LLM for unstructured reasoning. LLM could be very good at it. We use rule engine and Clara for structured reasoning. We use LLM for what to do. We use Clara for how to do it. For example, we can fetching data from the hierarchical table is kind of the structural thing. From unstructured reasoning is user give some inputs like I want a village name plus province name, and we get some output. Some remain piece of puzzle. I'm going to speak them pretty fast. Designing conventional electronic is hard. You need to know lots of things. There is new trend in the electronic, which is modular electronic. Even non-electrical engineer like me can build any system. I think anybody or any domain could be decomplexified by the same technique, which is modularizing thing, uh, making some interfaces for those modules and just wiring those interfaces with each other. As we told before, or we have architect, LLMs, we have engineers, and we have workers. The problem is that these three components are not speaking the same language in the same format. For example, our architect is Italian, or or logic programming or engineers speak German, and our worker are Turkish. So how could we connect to them? How could they pass data between each other? Between LLM and Clara, we would use a high-level DSL, and between Clara and closure postwalk, we will use low-level DSL. DSL is not a jargon thing. It's just a map, series of map, which we use to represent each step and what to do in each step. And these would parse all the data. So it is the same. For example, the map in the blue is the same as the map is above. Maybe we think that what is above is simpler. Yes, it is simpler for us, but not very simple and very understandable for the Clara. So Clara could easily generate what is below, and it could be parsed by the closure postwalk. Okay, an example of we will review an example here, defining a mock data sets schema. We define the mock data sets. This is user prompt. I want a village name plus province name of it. It LLM generates high-level DSL, select village name, province name. Low-level DSL is generated by Clara. Closure walk start walking toward this low-level DSL and do all the join, and we finally get the result. Some of the examples are already in the repository, especially this part of the talk, but I will also push some other examples related to Yuga Center pretty soon. These are my contacts, and thank you, by the way.
Thank you, Siavash. We can take some questions. That was great, Siavash. You covered a lot of ground in there and quite complex, like 700 tables. Can't imagine that. Okay, I had a question, Siavash. Like, so LLM generates high-level DSL. So how would LLM know that these columns are available? Like it generated name, village name, but how did it know all the columns that are available?
In the main project, I use tags, information tags, and when the work of LLM is, I give it the list of tags, and it understands what tags are required and what operation required is that tag. And there is also a different table which has relation between tags and tables and tags and columns, and the other part is not related to the LLM. The first part, which is understand these prompt want which informational tags, and then the rest is work of uh, Clara.
Thank you.
Thank you.
Maybe can I ask, uh, Siavash, if that's something you wish to talk about more, would you like to tell a bit more about what you do with the big data sets, with those 700 data sets, and the type of problems you run when you do that, as much as you can share?
Yep. Data sets are related to villages, and there are lots of data there about every species exists in the village, every kind of tree, uh, about, for example, diseases, animal diseases, people diseases, if that village has a school or not, and economical, demographical, um, any kind of their language, what are their, because each village could speak in different language. Some village has mixed language and so on. What are their birth rate, what are their divorce rate, and so on, and for 17 years. Based on, because these villages are for all the country, in the Ministry of Agriculture, they can ask high-level questions. For example, what current economic trends affect the birth rate? Or the village in altitude X has mm, what are economical features in the village altitude X, for example? Or could we cluster village using, for example, their distance from the big cities and their economical situation, something like it. Very high level questions. And one important thing, the end user of it are not technical, are, for example, ministers and so on. So they, even they do not, even they do know data science, they are not, they don't have enough time to do all the things. They want to ask questions and get the result. Previous than this system, asking question takes, for example, amounts. They ask questions, they give it to some person to do it, and every part of data is gathered, analyzed, and go back to the top managers. but now it is just doing a very small time, maybe 5 or 10 minutes. Uh, yep. Clara is a kind of rule engine. Mr. Wood is asking that what is the usage of Clara here? Clara is a rule engine. You define the rule. For example, if data are in the separate table, how would you join those data to get to how would you join those data? For example, you add rule there, and then you ask the question. Logic programming is a different paradigm, but it has some similarities with functional paradigm. In the ideal logic programming, in normal programming, logic procedure equals to the program. In the logic programming, in the very ideal case, logic is equal to the program. So we somehow omit the procedure. So we do not need to ask different kind of don't need to write, for example, if we have 20 combination of situation, we don't need to write 20 functions. We just define the rules and we can ask it, and the rule engine would generate the result for us. It can reasoning about things. And one good feature of it is reasoning very fast. And it can go back and forth between the data sets very fast, so it does not have the issue which LLM has. For example, DeepSeek, which is very good large language model, takes huge amount of time for answering one question, but Clara is answering in a second or less even. And also you cannot ask LLM with too many rules. For example, you want to ask LLM for analyze a thing. You cannot give 1,000 rule, 1,000, 10,000 rules. Okay, based on this, calculate this. It cannot do that. But Clara could do that even under a second, and very reliable. And no matter how much complex is a data set, just you or how many rules do you have, you just give it the input and you get your required output from it.
Okay, thank you, siavash. I'll have to check Clara out.
Yep. It is pretty interesting, and it is even using it is easier based on my experience than mini-convert. Core logic is less both performant and somehow harder to use.
So, Saivash, if I understand correctly, did you write one rule for each table and then fire them up based on the high level DSM that LLM gave?
No.
Okay.
No. Tables are not hard coded in the system. Any Postgres database could be imported to the system or not, because database are continuously changing. New database, new schema, new table could be added. The rule engines is required how you would join the results, aggregate the results, using something like a table plot, and represent the results, make what results should be done first, what results should be done the second, what should be third, and so on. This is related to general thing, not a specific thing to the domain, which is the agricultural database. So we could use any other database and get the results.
I understand. Thank you.
Yeah. Can I ask another thing? So we heard about Siavash's project a bit earlier because Siavash was presenting it in the SciNoj AI group. And it was actually, I think, a special moment for that group because it was one of the first times where we got to hear about something new in terms of methods in Clojure that could then be maybe explored together in our community sessions. And I think, Siavash, you were very open to exploring that. And maybe if you wish, Siavash, would you like maybe to say something about your hopes of things we could explore later on community projects, combining logic programming and LLMs?
Yep. I'm really eager to research about these things, and also I'm open. We could join and research on it. We can publish papers, both scientific and conference papers on combining these two techniques. There are also some other things we can do, like changing internal of an LLM to somehow put some logical reasoning there. These are things, but the most practical thing is some researching on it, and also we can somehow broadcast on it. We can use it on different domains. For example, one thing I am really eager to do it is generating the 3D models using OpenSCAD and prompt, I want this model, and LLM generates some high-level DSL, high-level things, and the Clara generate the low-level things, and it finally generate the OpenSCAD model, which could be imported in something like FreeCAD or any other 3D modeling software. And also this technique is different than 3D diffusions model, which is done by some repositories. So I think these these design patterns using the abstract reasoning to the LLM and more concrete reasoning to the logic programming could have several implications, not just related to data mining. It can relate it to the low-code platforms and building software. It can relate it to mechanical engineering, like what I said in generating 3D models and so on. So I'm really eager to search on this area, and I really appreciate if you want to join, or if we want, we can build a stream or a group in the Clojurian Zulip and continue the talks or research and finding together there.
Yeah, thank you. This helps a lot. Yeah. Would it make sense to talk about geography for a moment? About your experience computing with geography, Siavash?
About geospatial database, their queries is different than the normal queries. I was using PostGIS, which has both geospatial types and also geospatial queries inside the Postgres. You would, for example, want to find, for example, village farms around the border of the province. You need a special function using the Postgres if you want to find the intersection between, for example, two atmosphere sensors. You need these kind of things. You need those geospatial operations. So if you want to work in GIS things, you need to somehow master these geospatial queries. And also there are other tools which are related to geospatial servers. So sometimes you don't want to do your geospatial queries inside the database. You would fetch them in the memory and you do your queries in the memory on the geospatial servers, which is something that would be used in a more mature project or more real-time project. And at the end, I think one important thing which is really both valuable and is a trend in using agricultural GIS is combining the land data which you are getting from the land sensor with the aerial data, with remote sensing data like UAVs and also satellites and satellite image processing. And I'm not yet dive into the satellite image processing, but I'm really interested in processing satellite image. You can understand lots of things from it. You can understand if a farm has disease, if a farm needs watering. For example, one part of farm could have water tension. You do not give enough water to it. You could understand it by satellite. So unbelievable amount of data you can get from the satellite. For example, one important implication is insurance. When the flood happens, want to understand that how much damage is actually made. And without using tools like satellite images, it is really hard. You can assess the correct amount of damage. So these are very important implication of satellite images and also using remote sensing data in combination with land sensors to build GIS. So these things are really both interesting and both is really helpful to the community, to the farmers, to the global warming. If you just reduce the amount of waste in the agriculture that is caused by different factors like water tensions, wind, and so on, and you can reduce that, it means it means that there is less CO2 is produced for chemical fertilizer and so on. So I think this domain is really interesting to work both from economical point of view and also from a humanitarian point of view as well.
Thank you so much. Very detailed explanation, and it's great to learn. Today I learned that satellite you can get very specific whether the plant was watered or not. It's a great lesson. So many things.
You're welcome. You're welcome. Yes, this is really interesting.
There is a little comment in the chat, in the Zulip chat, a little question.
Yeah.
Maybe it is good to repeat the question, if that's okay.
Does the LLM sometimes fail at generating the high-level DSL, like hallucinating or using invalid construct?
Yes, LLM could hallucinate in generating the response. So we can reduce the probability of it. As in the first step, we are using, I'm using Spacey, which is a NLP library for entity name recognition. So at the first place, it helps the LLM to understand things and do not hallucinate about things. As I'm using DeepSeek, DeepSeek has this automatically you can say that if you fail to generate in the different if you fail to generate the output, you can retry 1 time or 2 time or 3 time or so on. So it is already implemented in the DeepSeek API, which is very good. And also if you reduce the output size, which is you are asking from the LLM, or you ask especially from LLM if you do not know something, ask the question, for example, instead of I ask it for geospatial data, I ask me tell me a joke, it should then return error. It is not related or something like it. And the third technique is a supervised technique. So you have 2 agents. First agent is generate the response. Then the second agent act as a quality control and analyze it and decide that it is valid or not valid. These are techniques for reducing the amount of errors. But I didn't use the third technique in my project. The first 2 techniques is suffice for me.
Thank you, sir.
Thank you, Ambers.
We are at time. But feel free to use Zulip chat if you want to discuss.
Okay.
Okay. Yeah, a lot of things we learned in this session. Siavash, thank you so much.
Thank you. Thank you. Thank you,
And
Daniel.
I learned always, like we said, always it's like you feel that you have figured out how to use LLM and then LLM hallucinates and then you have to readjust. Like you said, we have to write another agent sometimes. Which was the point. Thank you.
Thank you.